Welcome to VC Electronics. This is a video on ISRO Scientist Electronic Post Preparation, and we are going to see the questions from last year Scientist exam, that is 2018 Scientist exam questions we are going to discuss in this video. Okay, so my request is that if you are preparing for either GATE exam or Technical Assistant exam, you should always refer the ISRO Scientist videos because they are always having a standard. Means there is some difficulty level with that questions, and if you are preparing those questions, you will be able to crack the GATE and also Technical Assistant exam. So this is my request. Anyway, let us see what is the first question for today's class. Determine the change of collector current delta IC due to the change in base emitter voltage VBE from 25 degrees Celsius to 100 degrees Celsius for a silicon transistor in fixed bias configuration, given that beta is 100. Now, in the bracket they have given, consider the parameter variations, that is T is equal to 25 degrees Celsius and then VB is 0.65 volt. At T is equal to 100 degrees Celsius, VB equal to 0.5 volt. So actually this question is a little bit difficult to understand. Anyway, I'll explain the question first. We need to actually find the change in collector current or delta IC we need to find. And this collector current is actually changing with the base emitter voltage, that is VBE change. There is a change in temperature also, and also there is a change in the VBE. That is, for temperature is equal to 25 degrees Celsius, VB is 0.65. And when T is 100 degrees Celsius, VB is 0.5 volt. Okay, so this is the given data in the question. And also it is given that the value of beta or the common emitter current gain is 100. Now we need to find the value of change in collector current. So here we are given the data like VB is given, beta is given, and from the figure, this is a figure given in the question. From the figure we know that VCC is 100, the value of resistor in the collector, that is collector resistor value is given as 1 kilo ohm, RB is given as 25 kilo ohm. Now we need to find the change in collector current. Okay, the options given are option A 60 microampere, option B 30 microampere, option C 15 microampere, and option D 120 microampere. So how can we find the change in collector current? The collector current is dependent with the base current, we know that. That is the relation between base current and the collector current is given by beta, which is IC by IB is equal to beta. That is the common emitter current gain. Here IC is the collector current and IB is the base current. And hence we know that the value of IC or the collector current is equal to beta into IB. This is a very simple relation when we study the configurations, different configurations of the transistor. So here we need to find this IC, then beta, which is equal to beta into IB. Now what is the value of IB? IB is the base current, right? So how to find the value of your base current? Base current is equal to, from the figure or from the general equation we know that VCC minus VBE by the resistor value at the base. We know that simply by Ohm's law also. The value of current is equal to voltage by resistor. The effective voltage at the base is VCC minus VB. Now, the value of resistance is the resistance connected to the base terminal, which is RB, right? So, the value is VCC minus VB here by RB. Now I'm going to substitute the value of this IB. I'm going to take it as 1 in my equation number 2. Okay, so what is the value? I'll write it here itself. Beta into VCC minus VBE by RB. Right. So this is the equation for your collector current IC. Now what we need to find, we don't want to find the collector current, but we need to find the change in the collector current with this temperature from 25 degree to 100 degree. That is, when there is a change in temperature, the collector current is also varying. Okay, and also it is depending on the base emitter voltage. So we need to find the collector currents change with this temperature. That is, we need to find DIC by DT. This is equal to your delta IC, which we need to find. Now applying this differential to the equation, that is equal to d by dt of your beta VCC minus VBE, again there is a bracket here, by RB. Right, I hope this is easy to follow. Now I'm going to take this beta to inside the bracket. Okay, so d by dt of beta into VCC minus beta into VBE by RB. Okay, in the next step, I'm going to split this denominator RB to both this beta VCC and beta VE. This is actually basic simplification. Anyway, I'll do it for you. I'm going to write it above. Okay, that is d by dt of beta VCC by RB minus d by dt of beta VBE by RB. Now, if you see this term, here there is a beta, there is a VCC and there is a RB. All these terms are what? Constant. And if you take the differential of this constant, it will be equal to 0. So, this is a 0 term. So, the value is 0 minus is your delta IC. Okay. So, here minus d by dt of beta VBE by RB. So, I'm going to remove all this. Now, this delta IC is actually what? It is DIC by dt, right? Now, if you see this term, the RB is constant, beta is constant. Because beta is given in the question, it is 100. RB is the value of resistance, it is not changing. It is 250 kilo ohms. So, I am going to take it outside, that is beta. The minus also I am going to take, minus beta by RB into d by dt of VBE, that is equal to your this term, that is DIC by dt. Now see, the value of VBE is changing, right? That is, if T is 25 degree, the value is 0.65, and when T is increasing to 100 degree, the value is decreasing to 0.5. Okay, so what is the change? That is, as the temperature is increasing, the VB is decreasing, right? So the change is 0.5 minus 0.65 is a change. Higher value minus lower value. The temperature, because it is changing with dt, as a T is increasing, the value is decreasing. So it is a negative change. So minus, what is the value? Minus 0.15, right? This is a change. Now applying this d by dt to this side, what will you get? That is DIC by dt is equal to minus beta by RB into, the value of change is minus 0.15, right? If you subtract this VB change or the values, we will get this value. Okay, so now applying the other changes or other values here, beta is 100 minus 100 by RB is 250 kilo ohms, that is 250 into 10 raised to 3 into minus 0.15, right? So 100 into this minus and minus will get cancelled. 100 into 0.15 is 15. So it is a 15. 15 by 25. Okay, I can take this here. That is 15 by 25. If you cancel it, 3 by 5. So, sorry, 3 by 5 you will get. Now, 3 by 5 is 0.6. 0.6 by 10 raised to 4 or 0.6 into 10 raised to minus 4 you can write. Also, the value is given in, so this is a change actually. Delta IC value is obtained as, the delta IC value is obtained as 0.6 into 10 raised to minus 4 ampere. This is a current change. So, the values are given in which unit? It is given in microampere. So, we need to find a microampere current. So, 0.6 into 10 raised to minus 4 can be written as 60 microampere is your answer. So, this is your delta IC value. I hope this question is clear. So, in the question, we are actually finding the change in our collector current. So, this collector current is depending on the temperature because the temperature is actually causing a change to the VBE value. So, we are given the two temperatures and also we are given the values of your change in VBE. So, we need to find actually this change is happening to your VBE or emitter, base emitter voltage. So, we are going to find the change in collector current by applying this change to your VBE. That is, we know that the relation between IC and IB, that is the collector current and base current, is IC is equal to beta into IB. And then we are going to apply the equation for IB, which is equal to VCC minus VBE by RB. So, hence by applying the change to inside, we can find the value of change in our collector current. Okay, so this is how we need to do this question. I hope it is clear. Question is, electric field of 1 volt per meter is applied to a boron doped silicon semiconductor slab having doping density of 10 raised to 16 atoms per centimeter cube at 300 Kelvin temperature. Determine the approximate resistivity of the slab. Consider, these are some characteristics given in the bracket. Consider intrinsic carrier concentration of silicon at 300 Kelvin is 1.5 into 10 raised to 10. Hole mobility is 500 centimeter square per volt second. Electron mobility is 1300. So, what all things are given in the question? Let us see. So, this is a boron doped silicon structure. That is, an intrinsic silicon is doped with a boron. And the doping density or Na is given as 10 raised to 16 atoms per centimeter cube. Now, if the intrinsic silicon is doped with the help of a dopant, that is an acceptor, we'll get what? We'll get holes generated in the silicon structure. And the number of holes generated will be equal to the doping density. Okay, so this Na is equal to P, which is the number of holes. Also, it is given in the question that the intrinsic carrier concentration of silicon Ni is given as 1.5 into 10 raised to 10 per centimeter cube. Hole mobility is 500. So, what is the letter denoting hole mobility? It is mu P for hole. 500 centimeter square per volt second. Now, electron mobility is mu N. It is 1300 centimeter square per volt second. Now, if you are going for a competitive exam, you don't need to write like this. You can directly answer from the question. Anyway, I am just explaining. So, that's why I am writing this. Okay. So, P is equal to doping concentration is equal to 10 raised to 6. Ni is given as 1.5 into 10 raised to 10 per centimeter cube. Mu P, that is electron mobility, and hole mobility is also given. Now, we need to find the value of what? Resistivity. We know that resistivity is the reciprocal of our conductivity. Okay, so conductivity is represented with the letter sigma and resistivity is equal to 1 by conductivity, or 1 by sigma is equal to rho, which is our resistivity. So this is the resistivity and it is equal to 1 by conductivity. Now I am removing all this. What is the equation to find the conductivity? Let us see. Conductivity sigma is created by electrons as well as holes, right? So the equation for conductivity sigma is given by n into, where n is the number of electrons, into Q, which is the charge of an electron, into mu n, which is the mobility of electrons, plus P into Q into mu P. Now what is P? P is the number of holes, Q is the charge of electron, and mu P is the mobility of holes. So all the terms is known except the number of electrons. So what is the number of electrons? N is equal to Ni square by Na is the equation to find the number of electrons. Now what is Ni? It is given in the question that the intrinsic carrier concentration is 1.5, which is Ni, and Na is also given topic concentration. So you can substitute the value of N as Ni square by Na. Now we know all the terms in this equation, so we can find the conductivity, and if you take the reciprocal you will get your answer. So I am going to substitute the values here. Ni is 1.5 into 10 raised to 10 square by Na is 10 raised to 16 into Q is 1.6 into 10 raised to minus 19 into mu n is mobility of electrons, which is 1300, plus number of holes is equal to 10 raised to 16 itself, into Q is 1.6 into 10 raised to minus 19 into mobility of holes is 500. Okay, so closely examine the terms associated with the electrons, that is Ni square by Na into Q into mu n. So here there is a 10 raised to 16 in the denominator, and there is a 10 raised to minus 19 in the numerator. So if you take this 10 raised to 16 to the numerator, you will get into 10 raised to minus 16. Now there is a 10 raised to minus 16 here, 10 raised to minus 19 here. So these two terms will make a huge negative value, that is 10 raised to minus 16 plus 19 is equal to 35, right? So this is a 10 raised to minus 35 value here. So I can replace it here, 10 raised to minus 35. So this term into 10 raised to minus 35 means it is a very small quantity, and hence you can ignore this terms associated with the electrons conductivity. Now only rest is the P into Q into mu P term. So this will contribute to your conductivity. Now if you take it, there is a 10 raised to minus 3 here, minus 3, and these two zeros will make minus 1. Now this 1.6 into 10 raised to minus 1 into 5 is equal to 1.6 into 8 is 1.6 into 5 is 8. 8 into 10 raised to minus 1 is a value of your conductivity. Okay, so this is the value of your conductivity. Now, in order to find the answer for this question, we need to find the value of resistivity or rho, which is equal to 1 by 8 into 10 raised to minus 1, which is 10 by 8, that is equal to 1.25 ohm centimeter is the answer for this question. Okay, so the resistivity is 1 by conductivity, that is 1 by 8 into 10 raised to minus 1. So the value is 1.25 ohm centimeter, or D is the correct answer for your question. Okay, so I hope how we have done this question you understood. That is, we have first found the value of our conductivity, then we have taken the value of the reciprocal of conductivity to get the resistivity value. And the correct answer for this question is option D. The next question is, a reflex klystron is oscillating at 10 GHz when operated in 2 and 3/4 mode. Find the transit time of electron repelling space in nanoseconds. Option A 0.25, option B 0.275, option C 0.036 and option D 0.35. Now what is a klystron? Klystron is actually an electron accelerating or electron amplifying device. That is, we are going to increase the velocity of a electron in a klystron cavity. So there is an anode, there is a cathode. So electron is being repelled in between these electrodes, and we need to find, in this question, we need to find the value of the transit time. Anyway, we are going to do a video on klystron very soon. So if you want to study more about the klystron, please watch that video, okay? So the transit time we need to find. What is the equation to find the transit time of this electron? That is, transit time is the time of movement of electron between these electrodes. So the transit time T is given by n plus 3 by 4 by F. So we know that the klystron is being operated in various modes, and these modes, in various modes, we are going to vary the voltage and we are going to increase the velocity of the electron. That is happening. So this is the equation to find the transit time. So n plus 3 by 4 is actually representing the mode of operation. So it is directly given in the question that this this klystron is being operated in 2 and 3 by 4 mode. So this is actually 2 and 3 by 4. So this will be 2 and 3 by 4 by F. So the F is given in the question. F is equal to 10 gigahertz. So it is equal to 10 into 10 raised to 9. Okay, so this is the transit time. If you solve this, you will get the value of your transit time. So 2 and 3 by 4 is 4 into 2 is 8. 8 plus 3 is 11 by 4 into 1 by 10 nanoseconds. So this 10 raised to 9 will be, in numerator will be nanoseconds. So it is, if you solve it, you will get 0.275 nanoseconds is the answer for this question. So the transit time T is equal to 0.275 nanoseconds. So the correct answer for this question is option B. So this is actually a simple question compared to the other questions. Okay, so in the question paper of ISRO Scientist, you can find medium level questions and very tough questions. Normally very easy questions are rare. Anyway, if you practice more and more difficult questions, it will be easy for you to crack the examination if you are preparing for ISRO Scientist. Okay, so you'll be seeing with more questions in the upcoming videos. So if you found this video useful for your preparation, please do give it a thumbs up and also share this video with your friends. And if you want more videos for ISRO Scientist or Technical Assistant exam preparation or GATE exams and IBPS exams, please do subscribe to the channel. Thank you.